Okay, students, the next segment is what? Extrinsic semiconductor. We just discuss about intrinsic. Now, extrinsic semiconductor is what? The conductivity of intrinsic semiconductor depends on its temperature. Okay, but at room temperature, its conductivity is very low. So, what we do? Okay, no important electronic devices can be developed. Okay, using these semiconductors. So, what we can say that when a small amount of impurity is added, okay, in this intrinsic semiconductor, then what happens? Its conductivity increases, okay, and increase in conductivity is more available to make some devices like diode, triode, so many things are there. Okay, so for that, let's discuss about what is the addition of impurity in extrinsic semiconductor. Okay, materials such as the what you can say pentavalent impurity or trivalent impurity, if added inside intrinsic semiconductor, then its conductivity arises, and what happens? The process is called as what? Doping. A term is here called as what? Doping. D-O-P-I-N-G. Now, doping, you must have heard in Olympics also that dope test is being done for the players. So same way here the doping is what? To increase its conductivity without rising the temperature. Now in the segment of intrinsic semiconductor, I just explain you that when we rise the thermal agitation, when we give the thermal agitation for the intrinsic semiconductor, its conductivity increases, but without giving the heat, without giving the thermal agitation. If we increase the heat in the terms of semiconductors, okay, that is adding some kind of impurity, what happens? Its conductivity increases, and that is very responsible factor to make some useful devices. So what kind of impurities added inside the extrinsic semiconductor? Okay, there are two types of impurities. Okay, the first one is what? N type, and the second is what? P type. N type is called as what? Negative type. Okay, the impurities like pentavalent impurities like what you can say arsenic, antimony. Okay, if it is added inside intrinsic semiconductor, then you'll find that if we are considering what? Silicon, okay, its valence is 4, but we are adding what? A pentavalent impurity. What happens? One electron gets access, okay, inside what? The atom, and this electron is responsible for carrying the charge. Okay, now this is carrying the charge. So what happens? Without giving the thermal agitation, this charge carrier electron, which contains what? Negative charge, creates some movement inside the conductor, and you can say that electricity can created inside it. So simply you can say that this is a type of pentavalent impurity where the majority charge carrier is what? It is electron, and this electron moves inside the conductor. Okay, and energy required for silicon, it is something around minus 0.01, and for germanium it is minus 0.01, and for silicon it is 0.05 electron volt. By this way you can say that majority charge carries what? Electron, and this is also called as what? Donor core. Donor core means what? This one impurity out of 10 to power 6 of atom, we are adding only one impurity, and because of this what happens? The total process without performing any kind of heat, okay, is responsible for generation of flow of charge, and that type of impurity where the electron is the charge, majority charge carrier, is called as what? N type. That is called as what? Negative type. Similarly, okay, if we add the impurity like trivalent impurity like aluminium, bismuth in what? The same kind of conductor like silicon or germanium, what happens? These three electrons, the trivalent electrons, okay, creates what? No doubt it will make a covalent sharing with other 4 silicon atom, other silicon atom, that is the 4 electrons of silicon atom, but there you will find that due to its trivalent impurity there is the creation of hole will take place. Now this hole is what acts as a positive charge, but it is not a positive charge, it acts as a positive charge. And as we did in a pentavalent impurity, that electron is the here majority charge carrier. Now here is what hole is the majority charge carrier, and it wanders inside the atom and creates what current. Okay, so by adding this kind of impurity without giving any thermal agitation, okay, what we did, we just continued the flow of charge inside the atom. So that kind of doping is responsible to make the different kind of devices. Okay, so this hole or the charge carrier is also called as what? Acceptor core. It is also called as what? Acceptor core. So just I told you that two types of impurities addition inside what? Extrinsic semiconductor. The first one is negative type, in which we add what type of impurity? Pentavalent. Okay, don't forget the word pentavalent. And in P type we use what? Trivalent. What we use? Trivalent impurities. So here the majority of charge carrier is what? Electron, and in P type majority of charge carrier is what? Hole. You already discussed about the hole, that is the hole is what? The gap which is created due to electron. When electron left its position, there is the hole, and now this hole has such a type of tendency to attract the electron towards itself. Okay, that's why when the electron moves towards the hole or hole moves towards the electron, the flow takes place. So this is what the difference between intrinsic and extrinsic semiconductor. In intrinsic semiconductor you applied thermal agitation, and because of thermal agitation we saw what? The conduction of current. But for extrinsic semiconductor, if you have to create some kind of devices like diode, triode, okay, the devices which are allow to flow the current in only one direction, we use what? Such a type of impurities like N type and P type. Now in N type you also have to make a mind that here the density of electron is far greater than the number of holes. Number of density of electron is far greater than number of holes. In what type of? N type, because electrons are majority charge carrier. But if we talk about the holes, here the holes are acceptor core, they are the majority charge carrier, so their density is far greater than the number of electrons. So this is what you have to keep in mind, that extrinsic semiconductor is of two types. We just got the two types, N type and P type. N type contains pentavalent impurity, or the doping of pentavalent impurity creates what? Electron as a charge carrier, and here in P type this trivalent impurity creates a gap, and gap is what? That hole, and hole is what? One kind of charge carrier for positive type. So when you are writing the difference between N type or P type, these are some important topics which are to mention in the notes. Okay, and especially this one along with Ne far greater than NH, and for the P type NH is far greater than Ne. Okay, and you know how much impurity we add? Out of 10 to the power 6 only one impurity, that is we add only one molecule to the given whole atom, that is 10 to the power 6 means out in 10 lakh we had only one drop. In this also and this also. So this is all about what? N type and P type. So this is the end of the section of semiconductors and their parts. In semiconductors, I just revise once again, it is what? Intrinsic and extrinsic. What you have to keep in mind, in intrinsic you need to give what? Thermal energy. Okay, because of that it will work. But if we add some kind of impurities like pentavalent or trivalent, we do not have to give any kind of heat, and then we can create two types of impurities here, that is N type and P type. Okay, on the basis of that we can make many kind of devices. Okay, so I am sending you the page also, refer the page also very carefully and make some note, and whatever I spoken here, try to keep it in your mind. It will help you to write answer very perfectly. Okay, then I will start what? PN junction diode.